fit for this.
I think it's B. Which one do you think? Because yeah, it's if a student's arm length are directly related to their height. So that's two things. Bivariate means two pieces of data, right? Arm length is one set of data, and then their height is the other data. And that's probably a positive correlation because if you have longer arms, you're probably taller, right? Yeah. So I think it's B. Okay, find the line of best fit in the scatter plot. What? Okay, so find the line of, okay, so you're gonna draw the line of best fit, right? You're just gonna start right there. That's probably the line of best fit. It's just a straight line. Is that where the line of best fit is a line where most of the dots are closest to the line. Yeah. B, project the value Y, which is income, that's money, right? For the scatter plot when X equals 40. So when X equals 40, which is right here, most likely, right? If you look at it, I don't know, that looks like maybe 50. Y equals 50, right? And it's in thousands, so 50,000. Does that make sense? It looks like it's kind of tapering off right there. Does that look like it's kind of tapering off? It doesn't look like it's going straight up, right? Okay. Or actually it looks like a little bit over 50. So we can maybe put like 55. Well, X equals 55. Well, I would say maybe even 60. Let's put 60 instead. Okay. So this will be 60 and this will be 70. Do you see what the 70 is? So then when it says X equals 55, so just keep drawing. That's 50. That's 60. So 55 has to be right here. And this line keeps going right there. So it's about 70. Do you see how I kind of like projected over there? Yeah. So you could do that. All right.
Okay. Predict the X value of experiments when Y equals 10 and Y equals 75.
Okay. All right. Predict the value X. So now we're looking at X when Y equals 10, right? So when Y equals 10, so I would say 10 is like right there, right? I would say that would be like 10. That would look like it's maybe 2 years, maybe, right? Maybe approximately. It's not 100% accurate, right? Because we don't have the equation. 75 years. 75 is going to be right here. So I would say that's 50 years, maybe. 50 years of experience. That's just what I see, but yours could be maybe a little bit different, and that's fine. Okay. Okay. All right. Move on to the next part. Wait, hold on. This is a little bit off. No, it's fine. All right. What function best represents the scatter plot below? This one is going down this way. Do you see that? I will say this is exponential because it's going down really fast, okay? Exponential decay. Do you see that? This one, I would say there's no correlation. Or you could say this is a negative correlation. Okay, I think he probably wants negative correlation. This is no correlation. You could say this is also a positive bell curve. Okay. And a bell curve just looks like this. It goes up and it goes down like that. Does that make sense? Okay. All right, we're finished with the first page. Second page, here we go. What's the second page look like? Let me see. What does it have? Okay. Let me find it.
Number 4, I'm pretty sure consists of using.
Okay, let's take a look. He's never even talked about regression. What the hell was he doing with this? Okay, you see how this one says y equals ax squared, blah, 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 blah. Okay, so just plug in the a, b, and c into that equation, like ax squared. Put the numbers in there. If it's negative, the negative matters. Let me get you a better answer for this. He's never talked about this ever.
Okay.
Do you remember when we talked about quadratics and linear? Do you remember that? Which one do you think is going to be a quadratic? A or B?
A.
A, because it has a square, right? X squared. Okay, so that one is a quadratic. Is a positive or negative in front of the x squared?
Positive.
You sure about that? Because didn't it say okay, so looking at this part right here. So let's take a look. Okay. So A is a positive, right? But B is a negative, correct? This is a quadratic because it includes an x squared term. I don't know why is it a regression. I think it's because of a negative. I don't know. You could just put quadratic to what type of regression equation is that? Let me ask. Hold on. Why is the first one quadratic? It's a regression because it represents a statistical method used to model relation between blah blah blah. Okay, so regression is basically just a typical word. Okay, so the only way that you need to, the only thing you need to worry about is just remember, if it is x squared, it is quadratic. Just put the word regression. Does that make sense? So x squared is quadratic. Okay. Then looking at the b, do you see b? It's an ax right here. There's no x squared, right? So this one is a linear regression. Okay. So if it is just x, it's linear. Does that make sense? Okay. So that's all I really need to do.
Okay.
Not anything too.
What is the regression equation of the rapid to the next degree?
Oh, so then you just plug it in. That one's pretty easy, I think. So it's just y equals nearest hundredth, right? Hundredth is, there's a dot. This one here is the tenth. Then it is the second number, which is the, so just two decimal places, right? So A is 1.68 because you're rounding up, right? X squared plus B b is a negative, so let me erase that. Negative 3.91, right? X minus 0.23. That is your equation. Do you see how I rounded it though? Okay, you just need two decimal spaces. So you look at the third, or you look at the second number, right? And then if it's bigger than 5, you look at the third number. Or actually, no. You look at the third number. The third number is bigger than 5, then you take the second number, you go up 1, right? Okay. Here's the same thing. Y equals A, so negative 0.49. That one you round it down, correct? Yeah. X plus B is plus 9.78. That's your answer.
Okay.
Okay. What is the y value of each equation when x equals 2? So this is going to be a little bit crazy because you're going to be plugging the y value in, right? Even with two equations, it's going to be kind of hard to do. So it's basically saying when x is equal to 2, you do y equals 1.682 squared, right? Which is times 4, correct?
Yes.
Minus 3.91 times 4, right?
Yes.
Minus 0.23. So you just need to multiply it out. Does that make sense?
Yes.
And then you gotta figure out what y is equal to, okay? This one, same thing. Y equals negative 0.49 times 2, correct?
Yeah.
Oh, this one's not 4, this is 2, sorry, okay? Plus 9.78. So multiply it out. Does that make sense?
Yeah.
Yeah, so try to go ahead and do that. I'm gonna use a calculator so that way I can check it with you, okay? So you do the first one. I know it's kind of a pain in the butt though, yeah. 0.68. Right. Let's see. Wait. Um, I'm gonna highlight the answer right here so you can check, okay? You're done. How was your day? Was your day pretty good overall?
It's okay.
It was okay. I had a really stressful day today, but that's okay. Like, it'll be okay. It's just stressful right now. It's stressful because it's finals week, you know?
Yeah.
Yeah. So, yeah, that's kind of expected. Let me know when you're done, and then we can move on, okay? Just a lot of stuff. Did he go over any of this with you guys? Oh, good. Number 7. What term relationship is by the scatter plot? Estimate the correlation coefficient. We'll draw the line that goes through. The first one looks like a linear, but it's a negative slope, right? So it's a negative linear equation, right? Second one, there's no correlation, right? The third one is a positive, it's a weak positive correlation, whereas A is a strong negative correlation because all of them are kind of in a straight line. Do you see that though?
Yeah.
Like weak today? Yeah, because he didn't teach you guys this at all. I don't remember going over this at all. Okay, so the actual wording for this one, I'm going to show it to you right here. Okay, so when you look at this part right here, the first one, the best way to describe it, it's going to be a strong negative linear relationship. Okay. And if you have to, yeah, it'll be like around a -1. -1 is almost perfect for a negative correlation. Does that make sense? Okay. Second one is no correlation. So around 0. It's 0 correlation because like a perfect one, okay, so like a positive one is a perfect positive linear, like this. Do you see that? A -1 is a perfect negative linear, like just a straight like this, like diagonal. Does that make sense? When it's 0, it just means no correlation. Does that make sense? So make sure you write down the correlation coefficient is 0. This one, the correlation coefficient is about -1. Okay? Very last one. This is like a weak, or in this case, it says moderate, right? Posilinear. So correlation is about, it's not perfect. It's not going to be a 1, but it's 0.7, 0.8. Does that make sense? Okay, so take a look at that. Copy it down if you need to. Okay. Okay, so you're okay with this right here? So just be careful with the words and verbiage. Strong, negative, linear. Another one is just no correlation. Moderate, or you could say weak. Does that make sense? Okay. So just be careful with the words, okay? And then remember, if the coefficient is +1 or -1, it is strong, right? And if R is 0, it's no correlation. If R is like -0.5 or 0.2, it's weak or moderate. Those are the verbiage. Do you understand? Okay. All right. What is the next question that we have? Oh, the exponent. Okay. So this one I think you'll probably be okay with because you've done this many times before. So the first one, remember, there's a 1 right there, right? 5mn. 5 to the third power is 125. You multiply 5 times 3 is 15. 6 times 3 is 18, right? Okay. For B. Do you see how there are 2 bases here? When there's 2 bases, you take the exponent, you add. Do you remember that? So it's x to the 25, y to the 12. C, negative times a negative is now a positive. It's a 3. A 12 plus 4 is 16. Oh, hold on a second. I screwed this up. I forgot. there's a 2 on the outside. Do you see that 2 right there? And I forgot that there's a 3 right there. Do you see that? That kind of matters. You take that 3, you put it to the 12, and you put it to 7, right? Mm-hmm. Negative A 36, B 21st. Yep. And then the next one is a. Okay, we're gonna negative 9 A to the. Well, here's the other thing. Like, is it negative 3 squared, which is a negative 3 times 3? Or is it negative 3 squared like that, which is a negative 3 times negative 3? Do you see the difference there? I think it would be negative 3 times negative 3, which would be a positive. Let's just put positive 1. That's fine. B squared. Okay. And then it'll be a negative 9 because you have a negative 36, correct? Do you have a negative 36? Yeah, because if you look at it, it's a negative number to an odd power, which is going to be a negative, right? And then A to the 44 is a 44. When you add it, 21 plus 8, or I'm sorry, 21, or 36 plus 8, right? It's 44, right? Yeah, okay. Answer. We put that as a positive 9, correct? This is a negative A. Did you put a positive A? It's a negative because it's a negative. You see the 3 right here? 3 is odd. So a negative to an odd is a negative. Do you remember that? Yeah, that's why. This one is even. So a negative number to an even exponent is a positive. Do you remember that? And the reason for that is because it was like a negative 1 times negative 1. You see how this is even? Positive 1, right? But if it's negative 1 times a negative 1 times a negative 1, there's 3 negatives. It's a negative 1. Do you see that? Okay. All right, D. Okay, I'm going to pause it. Go ahead and catch up. Okay, notice that there's a 3 right there. So you put it to the 2, to the x, to the y, which is 2 to the third is 8x to the 12, y to the third. Bottom stays exactly the same, right? 8 and 36, you can divide it by 2, right? Which then 8 becomes a 4. No, it's the same garbage can. There we go. I just had a small computer. Okay, so then what's going to happen is that becomes a 4 and that becomes 18, correct? Yeah. And then you cancel that to be a 2 and that becomes a 9, right? There's nothing on the bottom of the x, so x just stays by itself. But then if you look over here, you always move the smaller one. Do you see that? So your answer is 2 over 9. X stays on top. Nothing changes with the x. Seriously. And then y is on the bottom. 9 minus 3 is 6. That's your answer. Do you see that? All right. You ready to move on, or do you need to finish? Okay, remember, be careful with this. Watch. When you have a negative here, remember you gotta flip-flop it. Like, flip it, and then it becomes a positive 3. Remember that? Like, that goes up and that goes down. Yeah. Okay, give it a try. So to make this a positive, you have R12, 3R cubed, right? Then you distribute that to both because you see the parenthesis is on top and bottom, which is R to the 36 over 3 cubed is 27, R to the 9. You move that 9 up. You see that? 36 minus 9 is going to give you good 27. That's it. Okay?
Yeah.
All right, F. 36 divided by 4 is going to give me a 9. Okay? M has a 1. This is a 4, so I'm going to move that 4 down. So 1 plus 4 is M to the 5th. Okay? This is a negative. Bring that up. 6 plus 2, 8, right?
Yeah.
And this P is a negative. I just need to move it up. So P to the 4th. And this is your answer. Oh, that froze. That's your answer right here. Okay. For C, that's okay. Take it on. No, take it on. Because it's a negative 4. You can have a negative. You can have the positive. You move it up.
Okay.
There's nothing else to combine it with, but you can't have a negative one. You know what I mean?
Oh,
So you just move it up.
okay. Write the given miracle using rational exponents.
Oh, hold on. C. D. Oh, here.
Oh,
Which one's smaller, 5/8 or 2/7?
I think
No, 5/8 means that you have 5 spaces out of 8.
2/7.
2/7 means you only cover 2 out of 7. So you move that up, right?
Yeah.
What's 5/8 minus 2/7? Fine. You're right.
Okay.
There we go. Better?
Yeah.
Okay, and then did you do H yet?
Okay.
Okay. I have an answer highlighted, so give it a try. Whenever you're not sure about something, just go, okay, well, if it's A2 to the 3, do you see how it looks exactly the same except no fraction, right? You know that's a time, so it's A to the 6. So you know you have that times there too. Okay?
Yeah.
Number 1? Okay. All right. Evaluate the radicals. This is the one that wasn't too long ago when we did it. 225, right? You could do 5 times. Do you guys use a calculator there or no? Oh, good. Do you have one or do you need to bring one?
No, they provide us with like a scientific calculator.
Yeah. Oh, yeah. All right. So then, well, you know the square root of 25 is going to be 15, right? But if you're not sure, you could just break it down. Okay?
Okay.
I think that for B, it's 6 to the third, which is just 6. Hmm. Yeah, it is. 6 to the third. Right? Okay. Okay, well, this one, you can't subtract. They have to have the same square root before you can subtract. Does that make sense? So, 196, if you can use a calculator, so just grab your calculator. So 196 divided by 4 is 49. So it's 4 times 49, correct? Square root of 4 is a 2. Square root of 49 is a 7. So that's actually 14. Do you see that? 169 is just 13, isn't it?
Yeah.
So your answer is? Yeah. Next one. Ready to move on or not yet? It's okay. Okay, so remember this is the one where you have the number and you have a exponent on top. It's always power over root, okay? So when you put it back in here, power is inside this radical and the root is on the outside. Do you guys remember that? Okay, so this is a power, this is a root. Do you see that? D to 125, the root is 3, the power is 2. Do you see that? There's two 125s, okay? Now, I know that 125, you can break it down and you can use a calculator. So my suggestion on what you should do with this is grab your calculator and go 125 divided by 25, right? Which is going to be 5 times 25, correct? But there's like two of them, right? So it's 5 times 25 times 25, correct? You need 3 of them to come out. Does that make sense? But then with the 25, you could do a 5 and a 5 and a 5 times 5, correct? So let's count how many do we have? We have 1, 2, 3. Okay, that's enough. I have to take 1 5 out, right? And then I have another 1, 2, 3. So I can take another 5 out. There's nothing left, right? So your answer is just 25. If there's something in there, you put it back into the cube. Okay?
That further.
Well, you can't square any further. It's just 5 times 5, which is 25.
Okay.
Does that make sense?
Yes.
Okay. All right. You ready to move on to the next one?
Yes.
All right. The next one is 32. Power is 2, root is 5. So 5. You need 5 of a kind to take something out. But there's 2 of the 32s, right? On the side, I know 32 is 2 times 16, right? Then 2 times 8, right? Then 2 times 4. Then 2 times 2. There's 1, 2, 3, 4, 5. 5 twos, right? But there's squares. So there's actually 2, 2, 2, 2, 2, 5, 2, 2, 2, 2, 2. There's 10 now, right? You need 5 of them to get out. Well, guess what? There's one set of 5. There's another set of 5. So it's just 2 times 2, which is 4. You see that? Okay. You ready to move on, or what do you want to do? You could take some time if you need to take some time. That's fine. I'm not in a hurry.
Okay. Okay.
All right, next one.
And simplify each expression.
Yeah, this one is going to take a little bit of time, so I'm actually going to move this to another section. I'm going to move it down, which is fine. All right, so if you take a look at the first one there, do you see that this is a square root, right? It's a square root, so I need two of a kind. So 350. I definitely think 25 will go in there, right? Because 25 is a perfect square. So 350 divided by 25. Oops. So here, use a calculator. You have a calculator over there? My calculator going on.
I don't have
Um,
evaluating it. Good.
you want ice cream with that? Give me a little super ice cream. How about the one that's like low fat? All right. Did you use your calculator? So you have 350, correct? Divided by 25 will give you 14. So it's 14 times 25, right? Well, I know that the square root of 25 will give you a 5, so I'm going to put a 5 outside. You see that? 14 goes back inside. Okay, so the number's 9. B to the 7th, how many b's can you take out? There's 7 b's. How many do you need? No. How many b's? This is a square root. You need 2 b's to take it out. So there are 7 b's. How many b's can you take out? No, you can't. 5 times 2 is 10. You don't have 10. It's 3. Do I have one left? Okay. How many d's can you take out? There's 8 of them.
Uh,
There you go. That is your answer. You need to be careful with that because you got your numbers kind of mixed up a little bit. So do that one on your own. Give it a try. And then move on to the next one. Okay, the next one is cubed, right? So be careful with that. So 192, you could use a calculator. It's even, so you can always divide it by 2. 96, divide by 2 again. 48 divided by 2 again, 24. So 2 times 2 times 2, there's 3 of them times 24, right? Well, the 24, because you want to collect 3 of the same number first, right? And then it's 2 times 12, 2 times 6, 2 times 3, right? If you look at that, there's 1, 2, 3. So you could take out a 2. But then there's also 1, 2, 3. So it's another 2, right? Which means that becomes a 4, right? How many m's can you take out?
um, 2.
2. But there's an m left, correct? The answer is 4m squared cube root m. And that is your answer. Okay? Do you want me to give you a little bit of time so you can work on C?
Yeah. I didn't help yourself.
Okay, so then for C, do you see how this is? What you need to do is you need to go ahead and do a cube root on 64 and a cube root on 27k to the 6. Do you see that? Okay, cube root of 64 means you need 3 of a kind, right? And let's see, 64, I think it's going to be 4. Divided by 4, yep. There's 3 fours, right? So that's just going to be a 4. Do you see that?
So
27 will be a 3, right? Yeah, because 3 times 3 times 3 gives you 27. Now for the k, how many can you take out?
take out
2, because it's 6 divided by 3. And that's your answer, right there. That's it. That's the answer right here. All right, next one. This is a times, correct? So what we're going to do, so pay attention, times is different than add. 3 times 2 is a 6, right? And then 14 times 7. Whatever you get stays inside the square root, right? So 14 times 7 is 98, right? Now with 98, you can take things out. Now, here's the other thing. If you're like, you could use a calculator, correct? So if you have a calculator and you have 98 divided by 7 divided by 7, this is going to be a 7 times a 7 times a 2, correct? There's 2 of a kind right there, right? So it's 6 times 7, 2 stays inside, which is a 42 square root 2. Do you see that? Now, here's the other thing. Look over here. Do you see how you have a 7 right here, but you know that this is a 7 times 2, which is 14? Do you see that? You need 2 to get out, correct?
Yeah.
Well, I don't know what the hell happened. Well, you have 2. You have this one and this one, right? So that comes out, no more square root, but this one stays inside. But do you see how it's exactly the same, though? Okay. So different ways of doing it. You can see it however you want to see it, okay? That's your answer. All right, I'm going to pause it. Pay attention, please. For E, what we're going to have is, if you look at this 3x, you can't combine it with this one unless it has a 3x as well. Does that make sense? But the 2, you can break it down. It's a square root, right? So it's 4 times 3x. Do you see that? 4 comes out, becomes a 2, correct? Right? 4 times 2 is an 8. So you have 3x in here, plus 7, square root 3x. I don't know what the hell is happening here. When it's a plus sign, you can add them as long as you have the same radicand, which is a number inside the radical, right? 8 and 7 then becomes a 15 square 3x. That's your answer, okay? All right, so then for F, what you can see here is, I know for a fact that this is going to be a 3, right? Because it's cube root, right? I don't know how it's happening. So 2 times 3 is 6. I also know that I could take a k out, right? But then I have a k left over, correct? 64, I could take a 4 out. So here's a 4. K, this k, you don't have enough. So that just stays in there, right? But then guess what? Don't I have the same k inside there? I have the same radicand, right? So 6k minus 4k is 2k. Cube root k. And that's your answer. Okay?
Okay.
So catch up and then we'll move on. All right, so inequality, if you take a look at this, it says identify a solution to a system is 2, 3 a system to the following system of equation. This is an easy one. The trick here is, you know, this is x and y, right? Plug it in here, plug it in here. If it equals 9, if it equals 5, then yes, it is, right? So this is easy. 2 plus 3, does it equal 9? No. So not solution. That's an easy one, right? But then if you take a look at B, this is not as easy. So if you look at B, which one should you plug in? Which equation looks easier to plug in? Top or bottom?
Top.
Okay, I say bottom mainly because there's no negative and the y doesn't have a coefficient in the front. But you plug it in top, I'll plug it in bottom. Let's try it together.
Yes.
Yeah, it is a solution. And if it's a solution, you have to check top and bottom. You can't just check one. It has to be both. Do you see that? Okay, let's try C. Let's try both for C. Okay?
Okay, you do.
No, I want you to try both.
Both.
If one is not a solution, the other one doesn't matter. It's just not a solution. Okay? But if one is a solution, you gotta check the other one, make sure. All right, go.
Identify a solution to a system as infinite solution or one solution. Create a system of equations for each system to have the following type of solution.
Okay, infinite solution means, infinite solution means it has to have same line. Like y equals 2x plus 1, y equals 2x plus 1. These two have to be exactly the same. Because remember, this is literally like one line lying on top of the other line. Do you remember that? And every single little piece, every point that they touch together is a solution. Okay? No solution is easy. This is just parallel. Slope. Same slope, right? Like they're not touching, right? But they have to have the same slope, right? One solution, it's just okay. One is probably a positive slope, the other one is a negative slope. Do you see that? Because they're kind of like perpendicular. So if your first slope is 2, perpendicular slope is going to be negative 1, 2, 1 over 2. So you got to have opposite, okay? Infinite has to be the same equation, right? What's the equation that's the same? That will be the equation, right? Now, you could make it a little bit fancier and write that equation in standard form, right? How would this look like in standard form?
For x or minus y equals 9.
Good. Yep, that'll be it. Yeah, it has to be exactly the same, right? And these are exactly the same.
Okay, so
No. Look. Negative 4x plus y equals negative 9. You cannot have a negative in front of the x, correct? So you change to a positive 4x. Positive 1 becomes a negative. Negative 9 becomes a positive. Do you see that? So this equation, the one I'm highlighting, that's the same equation in standard form.
oh,
Does that make sense?
yeah.
That's fine. For B, no solution. You just need to find what's the slope of the first equation.
5, negative 5.
So yours have to have a negative 5 as well. And then the B doesn't matter. It could be 0, it could be 1, it could be 5, it could be 8. Doesn't matter because there have to be parallel lines. But it has to have the same slope to make it railroad tracks. Does that make sense? All right, next one. One solution. Well, that's an easy one. Just go y equals. But the positive slope, you just make it a negative slope. You can do a negative 1 over 2x minus 1. It just needs to be like an opposite slope, okay? If one slope is positive, make the other slope negative. You can make it perpendicular even. What will be perpendicular of, or 1? Negative x minus 1, right? You can make it perpendicular. As long as you have a perpendicular slope, it would definitely crisscross and make 1, okay? All right, A. Let's go.
Solve a equation by graph.
Okay, so let's explain graphing. Let's look at the first equation. First equation is right here in blue. How do I graph it? Start with a B. And what's your slope? Over. So start at 7. And you go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. You draw your line. Remember that? Draw that. Here's a ruler. Then you grab the next one. Okay, so then I'm gonna move on to the next part, which is B. But if you look at B right here, I'm gonna stop you for just a second. If you look at B right here, do you notice how the first one's in standard form? You gotta rewrite it so it's y-intercept form. So yeah, so then we start at 5. 1, 2, 3, 4, 5. Down 1 over 1, down 1 over 1, down 1 over 1. So here's your line for the first equation. Second equation. Start at -3. 1, 2, 3. Go down 1 to the right side, down 1 to the right side. Okay, what do you notice about the slope of this one? Yeah, this is a -1 over 1. The slope of the first one is also a -1 over 1. These are the same slope, so they're parallel lines. So what's your answer? Because they're never going to touch and crisscross. Does that make sense? Okay, so you catch up and then we'll finish up. All right. Solve a system of equations by substitution. Do you remember substitution? Remember what substitution, it means to replace, right? You got to have one equation, okay? Need one equation, either x equals something or y equals something, right? And the other one's usually in standard form. Do you understand? So in this case, which one are you substituting? You're substituting x or are you substituting y for a? Which one's set up properly? Okay, do you see how this one says y equals 2x minus 3? In the take down, where are you going to put it? It's y equal, so you put it in right there. Y, correct? So replace it now. X plus, rewrite the first equation. Y, you replace it with what now?
2x minus 3.
Great. Now combine like terms. When you combine like terms, rewrite it. Add the 3 on both sides. Oh, this is a shitty question. It doesn't even give you a perfect number. Ugh, it's terrible. X is 8 over 3. Do you see that? But we're not done yet, because now what do we need to have? What do we need to find out?
Find y.
Yeah, which equation they use to find y? Top one or the bottom one?
The
Which one looks easier?
bottom.
Bottom, because it's already set up. It's y equals your answer, correct? So then you just do y equals 2 times 8 over 3 minus 3. 2 times 8 is 16. So you have 16 over 3 minus 3 over 1. You got to find common denominator clearly. So then we're going to cancel that to a 3, which is a 9. And 16 minus 9 is 7 over 3. So your answer, when you write it down, 8 over 3 is x, 7 over 3 is y. And that's your answer. Okay? The next one for B, when you take a look at B, what are you going to substitute? Which one's already set up? Remember I told you there's always one standard equation. Do you see the standard equation? Which is the ax plus by equals c. That's the top equation. And the bottom, what does the bottom say? Didn't I tell you there's always one that's x equals or y equals, right? For substitution. So for this one, what am I substituting? What am I going to replace?
X on top of y plus 2.
Good. So I'm going to take this and put it right there. But because there's a coefficient and it's a parenthesis, you got to be careful. So you're going to do 2 parenthesis minus y equals 3. And what I'm going to put inside is y plus 2. But you do have the distribute, right? Which then you get 2y plus 4 minus y equals 3. You want to combine your like terms. Solve for y. Second part of this, what do you need to find?
X.
Yes, you do. You need to find x. So which equation are you going to use to find x? Which one's already set up properly? Bottom's already x equals, right? So then you're going to plug that in, which is y plus 2. I'm sorry, negative 1 plus 2, which is just 1, right? So your answer has to be in the form of a coordinate. X comes first, then y, and that is your answer. All right, finish your first page. Let's go into the back side of this because you're not home yet, so we still have a little bit of time. Is that the only page you have, or is there like a backside to this? Is this the only one?
Yeah.
Oh, cool. That he didn't make it super difficult. That's good. I like that. All right, let's just finish the top part of this. Don't roll your eyes at me. I'm trying to help you here. I see you doing that. I don't like it. Bad bet, Pookie. All right, let's just go over to the back of this, and then tomorrow we only have one page to go. Just this one right here. Ah, shit, what just fucking happened? I'm gonna put my foot on your head. Better watch it. No, yeah, you did. Don't even lie. Don't even lie. Don't even lie. You're a bad kid. Not gonna get any more of those. Just remember that. Okay, over here. Let's just finish this one. This one right here. Oh my gosh, what's wrong?
Yes, but then basically I just have 2 pages.
Yeah, you did, right? Okay, so let's go ahead and take, well, then you'll just have, yeah, let's just finish the top part right here because it's radicals. And then after that, we'll just stop. How about that? Okay. All right, so G, this is a distribute, correct? You take this and multiply here, take that, multiply there. Now, you have to be careful. You're going to take the square root of 3 times the square root of 6. You see that? The 4 stays as is, but then that becomes the 18. Do you see that? Plus the 3 times that. So you're going to take the 3 times by the 15, right? Which then becomes a 2 square root of 45. You can simplify them, right? 18 is a 9 and 2. So that's a 3 square root 2, correct? 4 times 3 is going to give me a 12 square root 2, correct? Do the same thing with 45. You know, 45 is a 9 and a 5, which is a 3 square root 5. So 2 times 3 is a 6 square root 5. And that is your answer for that. I want you to do H and I and J on your own. Give it a try. That one's kind of a hard one. You need to be careful with that one when you're taking the test on this one. Just, no. You can't have a radical in the denominator, right? To get rid of that, you have to multiply the same thing top and bottom because this essentially is just 1. Do you agree with that? So it's 2 square root 8. Square root of 8 times square root of 8 is just 8, correct? So you have 2 square root 8 over fucking A is happening. Right? The 2 and the 8 becomes a 1 and a 4 square root 8, correct? But that 8 is a 4 and a 2, right? So it's really a 2 square root 2, I think, and a 4, right? Which then becomes a 1 over 2 square root 2. I don't know what the fuck is happening. It's like a ghost or something. It's just disappearing. But luckily I have a good memory. I'm memorizing them. This is fucking stupid.